In 6.2, we're going to be focusing on parallelograms and their different properties. The first thing that we want to take note of is just the definition of parallelogram is a quadrilateral, so it has to have four sides. It has to satisfy that first, with both pairs of opposite sides parallel. So these two opposite sides have to be parallel to each other. So we use these arrows to note parallel. Remember, if it's a tick mark, that just notes congruence. So that's the definition. Now, the theorems that deal with parallelograms, there's four of them here. So the four theorems say they all start, they have the same start. So if a quadrilateral is a parallelogram, so we're given it's a parallelogram, then the opposite sides are congruent, the opposite angles are congruent, consecutive angles, so angles right next to each other, are supplementary. So remember that's 180 degrees. They sum to 180 degrees. And then its diagonals bisect each other, divides in two. In two congruent pieces. Okay, so um, a lot of this can kind of be shown by a proof, but here we have some parallel lines by definition. So if these lines are parallel, we know that when we have a line that cuts through them, the corresponding angles need to be congruent, or alternate exterior angles would need to be congruent. Um, so anyways, we can kind of show that this angle is congruent to that angle. Those are alternate interior. This angle is congruent to that angle. This side is congruent to itself, so we end up with these two triangles. Okay, triangle 1 and triangle 2 being congruent. And once they're congruent, that CPCTC, corresponding parts of congruent triangles, are congruent. So therefore, this side is congruent to this side. This side is congruent to that side. So that proves that first theorem, theorem 6.2. Opposite angles are congruent. So this angle actually matches up with this angle over here. That proves the theorem 6.3. Consecutive angles are supplementary. These, I'm going to switch colors here. This angle and this angle, those are consecutive interior angles. And we know by the consecutive interior angles theorem that they are supplementary. Okay, that'd be how you prove that theorem. And the diagonals bisect each other. You'd have to draw in another diagonal here and show two more triangles congruent. I'll let you do that on your own, and we'll move on to a couple quick examples. So in this example, find the unknown measure. So what can we figure out about this picture here, given that this is a parallelogram? Okay, so if this is 5, we know the opposite side also has to be 5. This is 3. Okay, this diagonal is 3. Well, then this diagonal has to be 3. And do we know anything about any of the other sides? And, you know, some people want to say that you can use Pythagorean theorem, 3 squared plus x squared equals 5 squared, but this is not necessarily a right angle, so we can't do that. So this is all the information we can come up with there. Okay, using theorem 6.4 and theorem 6.1, if I got those right. Yep. No, 6.5 was the first one. Okay, so that's theorem 6.5, and this is because of theorem 6.2. Alright, so if this is a 120 degree angle, I know my opposite angles have to be congruent. Okay, that was theorem 6.3. And consecutive angles have to be supplementary. They have to add up to 180. So that has to be 60 degrees. Okay, and that's 60 degrees as well. Opposite angles are congruent again. This one will be similar. This is a symbol for parallelogram. So triangle, or parallelogram ABCD, where angle C is 105 degrees. So we can just make up a parallelogram, call this 105 degrees. Can we figure out our other angles? And remember, we got to go around clockwise, so let's go A, B, C, D. So angle A has to be congruent to angle C, so it has to be 105 degrees. And angle B and angle D have to be congruent, and they're supplementary to angle C, so they have to be 75 degree angles. 180 minus 75, or 180 minus 105. And here we have a parallelogram again, so my opposite angles have to be congruent, have to be equal. So I'm going to say 3x plus 18 equals 4x minus 9. Get my x's to one side first. Always start with your x's. It seems like it makes life easier. And I get x minus 9 equals 18. And add 9 to both sides. X equals 27. Okay, once again, we set this up where these angles are congruent. That was by the third theorem, I believe, 6.3. There's your homework. See you in class.